Today we're going to discuss the structure of categorical syllogisms and making a transition from inductive arguments, which we studied in the first two parts of the course, to deductive arguments. A valid deductive argument is an argument whose conclusion follows necessarily from the premises. In an inductive argument, in a good inductive argument, the conclusion follows at best with high probability from the premises. So why do categorical syllogisms qualify as deductive arguments? Aristotle created the categorical syllogism and discovered that these three-sentence arguments can be determined to be valid or invalid because of the structure of the arguments and the meaning of certain quantifiers. All, no, some. So if you look at the chart that I emailed you the picture of, there's a picture of 4 types of categorical statements, which I'll discuss shortly. So if it's a categorical syllogism, it's a 3-sentence argument, and each sentence has to be a categorical statement. This means that it has to be worded in such a way that it states a relationship between 2 classes of things. So categorical syllogisms are an example of class logic, where the variables stand for classes of things and not sentences. Okay, so in a valid categorical syllogism, there are only 3 sentences and only 3 terms or variables. If you look at the conclusion, there will be 2 variables, for example, all SRP, that state a relationship between the class of all S and the class of all P. A categorical syllogism can only have 3 terms. The 2 terms that are in the conclusion, for example, all SRP, and the 3rd term, which never appears in the conclusion, which is called the middle term. Okay, take a look at the chart that I emailed you. That one. And let's look at the 4 types of categorical statements. Now, before I do that, I would like to say that there are statements that don't appear as a statement of a relationship between classes of things, but can be put into a categorical statement. For example, the categorical statement, all A are B, can be applied to the following sentences. Girls just want to have fun, which would be all A girls are B, here's the class, people that just want to have fun. Or here's another statement that can be put into categorical form. Kids sure eat a lot of sugar. All A kids are B, people that eat a lot of sugar. Okay, so let's look at the first type of categorical statement, the universal affirmative statement. In the chart, the example is all poodles, all A, are dogs. The universal negative statement, an example, no A cats are dogs. The particular affirmative statement, some A students are B poor, and the particular negative statement, some A students are not B poor. A categorical statement will consist of 3 of those 4 statement types. They can all be an example of the universal affirmative. All terriers are dogs. All dogs are mammals, so all terriers are mammals. Each term appears twice. S in the conclusion and in one premise. P in the conclusion and in one premise. And M, the middle term that doesn't appear in either in the conclusion, but only in the premises, and does the essential connecting job between the subject and the predicate of the conclusion. So, referring to the outline, a valid categorical syllogism must conform to the following rules. Each of the variables, and we're going to label them S, M, and P, must be included in the three statements. The S term in the conclusion is called the minor term. The P term in the conclusion is called the major term. And the M term is called the middle term. There are 4 examples on your handout of valid categorical syllogisms. The first one, I already gave you an example. The other 3, all S are M, all terriers are dogs. No M are P, no dogs are cats, so it follows necessarily no terriers are cats. Let's use an example of the particular affirmative. All M students are literate. Some teenagers, P, are M students, so some literate people are teenagers. And an example of the particular negative, all persons, M, are S, mammals. Some persons, M, are not dogs, P, so the conclusion follows necessarily, some mammals are not dogs. So let's move on to the more specific rules of a categorical syllogism. And in order to understand and apply these rules, you have to understand the term distribution. So here's the second rule. The first rule being just basically a definition. Whatever term is distributed in the conclusion has to be distributed in the premise in which it occurs. So if you've got the, I'm giving you an example of an invalid argument that breaks this rule. Here's the invalid argument that breaks that rule of distribution. All M frontline infantry are S, men. All M frontline infantry are P, masculine. So all men, S, are masculine, P. Okay, so why is that an invalid argument? One thing you're going to have to consider when you're working on these categorical syllogisms is that once you put the complete argument with all the words in it into the structure where the classes are replaced by variables, I would recommend that you apply the rules to the structure and not consider whether it sounds right or makes sense. Because in a valid categorical syllogism, all the statements can be false. Validity and soundness are 2 different ideas. A valid argument is valid based on its structure. A sound argument is one that is both valid and the statements are true. While we're working on categorical syllogisms, we're not going to worry about the truth or falsity of the premises. And that's why I want to urge you, once you put the structure, the argument into its structure, don't think about the content. So what does it mean for a term to be distributed? This seems to be a problem for a lot of students, and if you at the end of the lecture still don't understand it, please email me. So here's the definition of distribution. A term is distributed if it says something about all members of a class. So let's refer back to the cardboard outline of standard categorical statements. The first one, the universal affirmative. All S, sorry, switching to A and B now. All A poodles are B dogs. Now, the question is, are you saying something in that sentence about all poodles? Yes, you are. Are you saying something about all dogs? No, you're not. You're not claiming in that sentence that all dogs are poodles. You're just claiming all poodles are dogs. So, in the universal affirmative statement, all A are B, A is distributed, the subject term is distributed, but the predicate B is not. I would like for you to take your outline of these four categorical statements and underline the letter A to indicate that in a statement all A are B, A is distributed. Let's look at the universal negative statement. No A cats are B dogs. In that statement, you're saying something about all cats, that they're not dogs, and all dogs, that they're not cats. So underline on your sheet A and B, because both subject and predicate of the universal negative statement are both distributed. You're saying something about all the A's, and you're saying something about all the B's. As a matter of fact, this statement is reversible. Its content is also indicated by no BRA. No ARB is equivalent to no ARB is equivalent to no BRA. Let's look at the particular affirmative statement. Some A students are B poor. Neither A nor B is distributed in that statement because we're not saying anything about all students that they're poor or all poor people that they're students. On the outline of on the chart, let's call it, I have two circles overlapping. The circle 1 and 2 is the circle of all students, and the circle 2 and 3 are the class of all poor people. I put an X in the middle, and that indicates that in the section 2, that indicates that there is at least one person, that's the X, that is a student and is poor. The X is put in the overlap between the two circles. Okay, so neither term is distributed. The particular negative statement, some A students are not B poor. As a matter of fact, B is distributed in the particular negative statement. It doesn't seem logical, it doesn't seem intuitive, but that's why I drew the picture of the two interlocking circles or overlapping circles. I put the X in circle segment 1. The first circle segment A consists of 1 and 2. The second circle B consists of 2 and 3. I put the X in the section 1 to indicate that there's a student and that student is not poor. Now, what makes B a distributed term in the some A are not B categorical statement? If you look at the picture of 2 and 3, the picture of B, it excludes the X. So it can be rephrased in a statement that's not that grammatical. The class of all poor people excludes at least one student. So B is distributed in the some A are not B statement because it's saying something about the class of all poor people that it excludes at least one student. Underline B in this particular negative statement. So there are 4 slots or spots in these 4 types of categorical statements that indicate a distributed term. The subject term of the universal affirmative, the subject and predicate of the universal negative, and the particular negative predicate term, the B. I would like for you to underline those 4 spots. Okay, so what is the sense? What's the meaning? What's the foundation for saying that if a term is distributed in the conclusion, of a categorical syllogism, it has to be distributed in the premise in which it appears. Let's look at the example on the lecture outline of an invalid argument based on failing to apply this rule. Okay, so I've got all M, frontline infantry, are S, men. All M, frontline infantry, are P, masculine. So all S are P. The reasoning behind why this is an invalid argument is this. If you're saying something about all men in the conclusion, all men are masculine, and you don't say anything about all men in the premise in which it appears, which is all M are S, S being an undistributed slot, it can't be a valid argument. It can't be a valid argument if the conclusion says something about all men, but the premises don't say anything about all men. So you can't logically reach a conclusion about all men if you have in the conclusion, if you haven't said anything about all men in the premise in which it appears. The second, well, that's actually the third rule. The third rule, which is also a rule about distribution, is that the middle term must be distributed at least once. The reason why categorical syllogisms work to reveal a valid as well as an invalid argument is based on the fact that the middle term, the term that only appears in the premises, does the necessary connecting job between the subject and the predicate of the conclusion. If you don't say anything about all members of the class of the middle term, it can't do the connecting job between the subject and the predicate of the conclusion. Let's look at my example of an invalid argument based on this problem. All S, women, are M, persons. All P, men, are persons, M. So all S, women, are men. It's invalid because the two times that M appears in both premises are undistributed slots. That means in those sentences, all women are men and all women are persons and all men are persons, you're only talking about some of the class of persons in each. So any argument in which M is not distributed is invalid. Looking back at the chart, that means that it can appear in the subject position of the universal affirmative. All M poodles are dogs. It can be the subject or the predicate of the universal negative statement. No M cats are P dogs. The middle term is not distributed in any particular affirmative statement. Some M are P. And it's distributed in the particular negative statement only if it's the predicate. Some A are not B. B is distributed in that statement. So M has to appear in any one of those four slots or positions in order for the argument to be valid. Next rule, nothing follows from two negative premises. That would mean either two universal negatives, one universal negative and one particular negative, two particular negatives, or two particular negatives. Okay, so if you claim, here's my invalid argument, no S, men, are M, women, that means the class of all men excludes the class of all women, and no women are male, no MRP. The class of all M's excludes the classes of all P's. You don't know what the relationship is between being an S, a woman, and a P, a man. So, although the premises are true, all women are persons, all men are persons, it's an invalid argument. Oh, I'm sorry, I'm looking at the wrong button. Nothing follows from two negative premises. No men are women, no women are male, so no men are male. Okay, I was on the wrong example. Okay, so in the first statement, you're claiming the class of all men excludes all women. In the second statement, you're claiming the class of all women excludes males. So the only thing you know about S and P, which are men and males, is that both of these classes are excluded from the class of women. So we don't know if all men are male, no men are male, some men are male, and some men are not male, because nothing follows from two negative premises. The next rule, a negative premise requires a negative conclusion. Let's look at the example of that argument. My first negative premise, some S football players are not M, short. Here's a universal affirmative statement. All short people are P, small boned. So some football players are small boned. Affirmative statement. So it's invalid because even though it sounds logical and even though it's true, some football players are small boned. You can't conclude that from the two premises because one of them is negative. The conclusion would have to be some S are not P, but even then, you don't have a valid argument because if the conclusion is some S are not P, P is distributed in that conclusion, but it's not distributed in the premise, all MRP. So merely changing it to a negative conclusion doesn't make it a valid argument. Okay, the last rule is that a particular conclusion requires a particular premise. So if you have a conclusion, some S are P or some S are not P, you have to have a universal statement. And I'll explain in a minute why that's so. Here's my first premise. All S leprechauns are M, Irish. Here's my second premise, also universal. All Irish people, beings, are P, Gaelic. So some S leprechauns are P, Gaelic. It sounds logical because if all leprechauns are Irish and all Irish beings are Gaelic, it follows that all leprechauns are Gaelic. So why would it be invalid to say some leprechauns are Gaelic if the conclusion all leprechauns are Gaelic follows necessarily? This is because when you have a particular statement, some S are P, some S are not P, in those two statements, an existence claim is being made. You're saying there exists at least one leprechaun, and that leprechaun is Gaelic. Whereas in the universal statements, all leprechauns are Irish. You're not saying that leprechauns exist. It's a function of the way Aristotle, who created the categorical syllogism, defines the term some in contrast to the words all or no. So when we get to the Venn diagrams next, it'll bring out why this is the case, that if you have a particular conclusion, you have to have a particular premise. Because referring back to the picture of the particular statements, you'll see that there is an X. In both of these statements, there's an X inside a partial circle. That indicates that there's something that exists that's in that partial circle. But if you look at the picture that I've drawn of the universal statements, for example, in the chart all A are B, the sections of the circle B, 2 and 3, exclude the section A. All the A, it's shaded out. It means there's nothing in that circle segment. And it's shaded out rather than being shaded in because it shows that nothing exists in that shaded out statement. It doesn't use the little x. It uses shade out what doesn't exist. In the universal negative statement, no cats are dogs. In the overlap between A and B, circle segment 2, the overlap between A and B is shaded out. There's nothing there. There's no animal that's both a cat and a dog. Okay, so those are the rules that determine whether a categorical syllogism is valid or not. There are 256 possible valid and invalid categorical syllogisms, but you don't have to memorize them. All you have to do is memorize these 6 rules. So let's take a look at the assignment, which I've emailed to you. In that assignment, it's on page 197 of the textbook. I've emailed you a picture of it. In that assignment, here's what I want you to do. Read the argument and decide before you put them into standard form statements, which of those 3 statements are the conclusion. I'm going to look for my copy of the homework assignment. Okay. Number 6. All good teachers are good administrators because all good teachers are compassionate individuals and all compassionate individuals are good administrators. Out of those 3 sentences, which is the conclusion? We'll look to see where are the cue indicator words in this argument. We've got the word because, and 2 sentences follow the word because. All good teachers are compassionate individuals, and all compassionate individuals are good administrators. Those 2 statements are premises because they follow the word because. The cue indicator words that indicate a premise are since, because, for the reason that. It could be something like if. So it follows that the conclusion is the first statement. All good teachers are good administrators. Once you've identified the premises and the conclusion, go to the conclusion. All good teachers are good administrators, and call good teachers S. Stands for the subject of the conclusion, and the class of good administrators P for predicate of the conclusion. And the term that's not, or the class that's not in the conclusion, which is compassionate individuals, is the M term. The M term, the middle term, appears in both premises, but not the conclusion. Okay, after you get your letters right, your variables right, all good teachers are good administrators, the conclusion, S, all S are P. The premise, all S are M. The other premise, all M are P. You've got the structure. So don't worry about the truth of the conclusion, all good teachers are good administrators. That sounds right given what came before. Just apply the 6 rules of valid categorical syllogism. If it breaks any one of the rules, it's an invalid argument. So on your homework for Wednesday, which will be due at noon, I want you to put those, 13 arguments into their structure. Each premise and conclusion has to be put into the categorical statement. All SRP, no SRP, some SRP, some SR not P. And you will have to decide as a result of applying the rules whether it's valid or invalid. When we do the test, on deductive arguments, including categorical syllogisms, you will not have to state which rule has been broken. But while we're still at the homework level, I want you to state whether the argument is valid or invalid, and if it's invalid, which specific rule has been broken. After we do these 13 arguments, I'm going to show you how to do a Venn diagram. And then you'll have two options as to whether an argument is valid or invalid. Whether it breaks any of the rules, or what the Venn diagram reveals about its validity, which I'll talk about on Wednesday. So, I think I've covered everything I wanted to cover as far as the information you need to know to determine whether a categorical syllogism is valid or invalid. If you have the textbook, it will be helpful, but not necessary, if you read the chapter. The chapter goes into a lot more depth than is necessary to figure out if a categorical syllogism is valid or invalid, because it breaks down validity in terms of truth tables. And it's interesting, and it gives specific letters to the 4 different types of categorical statements. It's not necessary that you understand or can apply all this additional information as far as truth tables is concerned, but certainly if you're interested in deductive arguments, it would make sense to read the chapter. So that concludes the lecture on categorical syllogisms. Good luck with the homework, and let me know if there's anything that you didn't understand in the lecture.